Good morning, everyone. Thank you for being here. Today, we're going to be doing a review for our test, and it's going to be in a week. So it's going to be on Monday after this Monday, 7 days from now, so it'll be next Monday. The first question that we're going to do on the test review is going to be, I'm going to read them out loud to you, and then I'm going to post this review in Moodle as well. Determine whether the statement forms not P and Q and the statement form not P and not Q are logically equivalent. So we're supposed to determine if the statements A and B are logically equivalent. So first of all, what do you think? Who thinks that those might? Raise your hand if you think they might be logically equivalent, and raise your hand if you think they might not be logically equivalent. So do you think that that makes sense? That maybe like if you say not P and Q, it's the same as not P and not Q. So you don't have to say yes or no right now, but how do you find out? Well, it says construct a truth table and include a sentence justifying your answer. So this is question number 1 from the review. Let me just make sure this is getting picked up. Okay, good. So question number 1. And I'm going to list the values of the variables. Hold on, this is on my iPad is tilting back and forth. Okay, there, that's better. List the possible values of the variables P and Q. So how do we start a truth table if we have 2 variables in it? What do we need to write down for the first variable if there's 2 variables total? Are you Arturo or Ignacio? Arturo, perfect. And you're Logan, right? Yes. Perfect. Okay. What do you have to write down for the first variable and note if you have a truth table? What do you start with? Every variable can only have 2 values. What are the 2 values that variable can have in a truth table? True or false? So how many trues should I start with? 2, correct. And then I need 2 falses. And then for the next variable, I need each possible pair of values, either true or false when P is true. And I also need either true or false when P is false. So this represents every combination of what can happen, right? Now I need to do the next column of the truth table. What column do you think should come next in the truth table? P. Say that again, P and Q, okay. So P and Q. So remember, whatever you do next should only involve 1 more combination of things than what you already have written down, right? So the next combination of things that's 1 more than what I have written down is P and Q. That's like putting 2 things together. So what is P and Q in the first line? What's true and true? True. Now what's P and Q in the second line? True and false is actually equal to false, right? Because if it says one thing and another thing, and if one thing is not true, then the whole compound and statement is false as well. And false and true is false. False and false is false. Remember, so an and statement can only be true if both A and B are true. That's the way it works in computer programming and in logic as well. Now let's pick another line for the truth table. So what's another thing that could involve 2 things, one more combination of than what we've done before? There's actually 3 options that could come next. Negative P and Q. Yeah, that would work. Because we've already done P and Q, so we could do negative P and Q, which would be, what's the negative of true? What's the negative of false? What's the negative of false? A negative of false is true. Now, we have two options remaining for what could come next. No, there's not just two things that come in the table, but we can only do two options now for what's next. So what are the two options that we could do next? Yeah, so negative P is one option. So what is negative P? What is the original P? Yep. Negative P is false, false, true, true. And then negative Q would come next. So there's only one option for that. It'd be false. The opposite of Q is false, true, false, true. Now there's only one further way to combine things together that we haven't done so far. Negative P or not P, I could say, and not Q. Now, what is not P and not Q? What is not P and not Q? Here's not P and not Q. So what is false and false? False. What is false and true? What is true and false? What is true and true? And we're supposed to determine one sentence or one reason why they're logically equivalent or not. So we're supposed to tell whether that's logically equivalent to this. So are those things logically equivalent or not? So in other words, is the truth table for that one, for this one right here, is that the same? Does that equal the truth table for that one or not? No, right? They do not equal. Tell me one line that does not equal. The first line is equal, right? How about the second one? Not equal. Third one, not equal too. So you can write a sentence that says these are not logically equivalent. Because two lines or two cases of the truth table are not the same, right? So it is not true that not P and Q is the same as not P and not Q, right? So this is question number 1 from your test review. So you're ready to get an A on that one, right? Okay, let's do question number 2. So question number 2 says use truth tables to, just a second. Got to keep track of attendance. Perfect. Perfect. Okay. And then, okay, there we go. Okay, perfect. So now the next one says P implies Q, triple line, not P or Q. So that says, oops, I left off a line letter. P implies Q. There we go. P implies Q is triple line, not P or Q. So that means P implies Q is equivalent to not P or Q. So we have to verify whether this equivalence is a true equivalence or false. So is this right or wrong? So is this right or wrong? We have to use truth table to do it with. So how many letters do we have in this problem? 2. So what should you start with for P? How many values? Since you have two letters, you need 2 to the power of 2 values. If you have 3 letters, you need 2 to the power of 3, because 2 represents the number of options for true and false. There's 2 options, true and false. And you do the power of how many letters you have. So if you have 2 letters, it's 2 to the power of 2. If you have 3 letters, it's 2 to the power of 3. If it's 4 letters, it's 2 to the power of 4, and so on. So we need to have 4 values for P. What are the values that I should have for P? I'm going to need 2 different options for true and 2 different options for false. And then what are the values for Q? I need 1 each true and false to go with each of the true values. And then I need 1 each true and false to go with the false values, like that. Now think of one small step we could do that's one more combination of logic than what we already have written down in the truth table. So what's one possible way to combine one more logical step than what we have already? Okay, I'm going to ask you a question. Could I add this whole thing to the truth table right now or not? No, because that's more than one logical step beyond what we've done already. What about could I just add this to the truth table? Yes, because that's only one more step logically than what I have before. So what is not P if P is what it is? Yep, correct. Now that I've done that, and now that I've calculated what not P is, now is it possible for me to add that whole thing to the table? Yes, right, it is. So now I can go ahead, because now that I know both sides of it, it only takes one more logical step to do the OR statement. So if you have not P, that's looking at this one, I'm going to circle it in green. And then it says OR Q, that's looking at that one. So those are the 2 columns that I'm looking at with an OR. So look at those 2 green columns and logically think of the word OR. So what's true? What is true or false? It's actually an OR though. So it's true or false? So if you have a computer code that says, if somebody wants lasagna or somebody wants pizza, let them go to the Italian restaurant. Well, if they want lasagna, then they should go to the Italian restaurant. Or if they want pizza, they should go, right? So true or false is still true when you have an or. That's true. What about the next line? Is that true or false? False. What about the next line? True. What about the next line? True. Because as long as one of them is true, then with an or, it still does that step. So true and true is true. I'm sorry, true or true is true, false or true is true, but only false and false or false is false though. So there's that. Is there anything else that we could do now with just one more logical step than what we've done already? How about that one? I already know P and I already know Q, so can I do one more step and connect them with an arrow? Yes. So P or Q. Now, by the way, there's not necessarily any right order to do the truth table. The only rule for the truth table is you can only add one more logical step at a time to the table. You can't do 2 logical steps at a time beyond what you've already added to the table. So since we already have P in the table and we already have Q in the table, connecting them with an arrow is only one more step to do than what we have before. So we can do that. But we also could have done, notice that we actually could have done, we could have done this step first. We could have done this step later, because doing P and Q only connects these 2 columns together, which is still just one more step than what we had before. And doing this column connects these 2 columns together, which so this column and this column could go in either order. There's no wrong answer for which one comes first. But right now that we're doing P arrow Q, so I'm going to circle that in purple. So P arrow Q is comparing those 2 columns with an arrow. So if you look at the PQ, if you say true, arrow true, is that true or false? True, arrow true is true. Correct. So that's true. And then true, arrow false, is that true or false? False. And false, arrow true, is that true or false? Correct. False, arrow false, is that true or false? Correct. So remember, it's easy to remember because there's only one time it's false. The only time an arrow like that is false is if it starts with true and ends with false. Because when an arrow starts with true and ends with false, that's like saying that somebody made a promise and they didn't keep it. So remember, an arrow is kind of like a promise. So if somebody says, makes a promise and they kept the promise, that's true. Somebody makes a promise and they break the promise, and that's false. See that? If somebody makes no promise, but they still kept it, that's still true. Somebody didn't make a promise and they didn't keep it, that's still true because they didn't make a promise. So remember, an arrow is kind of like a promise. The only time a promise is false is if you made a promise and you broke the promise. Now what could come last? There's technically, in this table, there's one more step. One more thing that needs to be logically connected together. What's the last thing that can be connected together? Well, we already have this whole thing in the truth table. Let me circle this in black. We already have that whole thing in the truth table, right? We already have that whole thing in the truth table right there. We need to now connect them together with a triple equals sign, which means equivalent. So actually, in fact, we don't even really need to do that actually. What does equivalent actually mean? Equivalent means that the truth values of that one, which is right here, are equal to the truth values of this one, which is right there. So are those truth values equal or not? Are those truth values equal or not? Are they equal in every single case? All four cases? Yes. So we would say yes, these are equivalent. Because we don't have to say the reason, but well, it actually does say that we have to have an explanation. It says that in the instructions. So these are equivalent because all cases are the same truth values, truth or false values, period. Any questions about that? Okay, then let's go to number 3 on the test review. So remember, the test is going to be a week from now. So a week, it'll be on Monday after fall break. So 3, this one says if, it says to write the negation, the contrapositive, and I'm just going to say contrapos for short, the converse, the inverse, and then that's it. The negation, the contrapositive, the converse, and the inverse for the following statement. The statement is, if today is New Year's Eve, if today is New Year's Eve, then tomorrow is January. So that's the statement, and we have to write the negation, the contrapositive, the converse, and the inverse. But we don't have to do them in that order necessarily, but we just have to do them though. So which one do you want me to do first? Let's do the converse first. Converse, I think, is the easiest to understand. Converse, you've heard of converse shoes before, right? The converse of a statement basically just means you switch the shoes to the wrong feet, or not the wrong feet, but the opposite feet, because maybe they're on the wrong feet already. So whatever feet they're on, you switch them. So that means you take the two parts of the statement, which is tomorrow is January, and the other statement is today is New Year's Eve, and you switch those statements to the opposite spots. So the converse is this. If tomorrow is January, then today is New Year's Eve. So converse just means switch the statement's positions, just like shoes, switch them to the opposite parts of the sentence. So by the way, which statement is true, the original one or the converse? So is this statement true? If today is New Year's Eve, then tomorrow is January. Is that a true statement? If today is New Year's Eve, then would tomorrow be in January? Yes. So is the converse true though? If tomorrow is in January, then does that always mean that today is New Year's Eve? No, because what if tomorrow is January 20th? That would still be January, right? If tomorrow is January 20th, does that mean that today is New Year's Eve? No, because today would be January 19th. So the converse statement is not always true. It could be true sometimes, but it's not always true, even if the original statement is true, though. So remember, the converse statement does not produce always, it does not necessarily produce a statement that's the same as the original statement. Okay, now after doing converse, let's do the inverse. Inverse is basically like, what if you put your shoes on the same feet, but you put them on backwards? Like you cut a hole in the back of your shoe, you put your toes out the back, and you have to have your shoes on like facing the opposite direction. So the inverse basically means that you put the negation of each statement, but you keep the statements themselves in the same position. So the inverse would be, if today is not New Year's Eve, then tomorrow is not January. So is that a true statement? If today is not New Year's Eve, then tomorrow is not January. So it's true right now because today is not New Year's Eve because it's October, and tomorrow also isn't January, right? But is it always true though? So what if it's January 1st though? So if today is January 1st, that actually is not New Year's Eve, right? But then tomorrow would be January though, because on January 1st, tomorrow is still January. So the inverse statement is not always true, even if the original statement is true. So that's the converse, that's the inverse. Now let's do the contrapositive. Notice the contrapositive is the longest word. Converse is kind of short. Inverse is kind of short. Contrapositive, let me write it all the way out. Contrapositive, it's the longest word. And it's the longest word because it does the most to this original statement. The contrapositive puts the converse and the inverse both changes together at once. So basically it switches the shoes onto their opposite feet, and it also turns the shoes around backwards to be the negation as well. So the converse would basically take what you did in the contrapositive would take what you did in the converse and what you did in the inverse and do both of them at once. So it would switch the position of the things. So it'd start with January. So it'd say if, but then instead of saying tomorrow is January, it'd switch the meaning of it to be not January. So if tomorrow is not January, then today is not New Year's Eve, right? So if tomorrow is not January, then today is not New Year's Eve. Contrapositive switches the statements from the original sentence to be in the opposite positions, and it also negates both parts of both statements themselves to be the opposite of what they said before. So instead of saying it is January, it said it is not January. Instead of saying it is New Year's Eve, it says it is not New Year's Eve. So that's the contrapositive. Finally, this one is just a specific thing you have to remember. What's the negation of a statement that's if something, then something? Oh, by the way, I left off one letter. I forgot. I meant to say then instead of the. If today is New Year's Eve, then tomorrow. Did I do that in? Okay, I did that there too. Sorry. Then, there we go. Wow, I did that all the time. Wow. I'm just getting lazy. Okay, so If tomorrow's not January, then today is not New Year's Eve. Okay, there we go. What's the negation of the statement if something, then something? So who remembers what the negation of the statement if A, then B is? What's the negation of A if A, then B? No, the negation of it does not have the word if or then in it, by the way, just so you know. So does anybody remember the negation of if A, then B? What's the negation? So what's the negation of if A, then B? What is the negation of if A, then B? So remember the truth table we just did a few minutes ago? There was only one time when the statement if A, then B was false. It was an arrow. Remember, the arrow means if A, then B. What's the one case when A arrow B is false? Remember, it represents a promise. What's the only time a promise is actually broken? Is if you make a promise and you break the promise. So the only time if A then B is broken, in other words, it's negated, is if the promise A was made and the promise B was broken, right? So if you promised A and then then you would do B, then if A happens and B did not happen, then you've broken the promise. So the negation of if A then B is A, the promise is made, and not B. That means the promise is broken. So the negation, therefore, of the statement, if today is New Year's Eve, that means the negation would be if, and then you say A. So if today is New Year's Eve, then, no, not then, and, right? So let me erase the comma. And by the way, you don't need the if either, right? In fact, I just said that a few seconds ago. The negation of an if statement is not an if statement, remember. It's an and statement. The negation of an if statement just is an and statement. A, so it just means today is New Year's Eve, and then it's not B, so it'd be tomorrow is not January. And tomorrow is not January. So the negation of if today is New Year's Eve, then tomorrow is January, the negation is today is New Year's Eve, and tomorrow is not January. Any questions about that? So these are all very important questions. You're going to have to know them all perfectly on your test on Monday. Okay, perfect. Now, let's go ahead and do problem number 4 from the test review. So 11010 base 2. It says represent this integer in decimal notation. So right now this is in binary notation. You have to represent the binary notation as decimal notation. So this is extremely critical. If you're ever working with computers, you need to understand how to convert from binary to decimal and back, as well as in other bases like base 8 and base 16. So any questions about what does 11010 mean? What does that mean? That means 11,010 in base 2, right? So mathematically, what does that mean though? What are the place values of base 2? What place value does the first digit have? Just like base 10, you learned this in like first grade or something, that's the ones place, right? So that's the ones place. And now in base 10, this is the tens place, remember? From like second grade or something. What place is the second digit though in base 2? Since it's not base 10, it's base 2, therefore that's the twos place, right? And in base 10, this is the hundreds place because that's 10 times 10 is 100. But that's not the hundreds place in base 2, it's because it represents 2 times 2. What is 2 times 2? 4. That's the fours place. And then the next one is not 1,000, because because in base 10, it's the thousands place. Like 10 times 10 times 10 is 1,000. But in base 2, that's 2 times 2 times 2. What's 2 times 2 times 2? 8. So it's the eighths place. What's the last digit represent? What do you think it represents? What's 2 times 2? What's 1 more 2? 2 times 2 times 2 times 2. What's that? 16, right? So this is the 16s place. So we have, how many ones do we have? 0. So we have 0 ones. So this represents 0 ones plus, how many 2s do we have? 1, 2. How many 4s do we have? 0. How many 8s do we have? And how many 16s do we have? Right. So of course, now it makes sense because we have basically 2 plus 1 8 plus 1 16. And what's 2 plus 8 plus 16? 26, right? So the answer is 26. So 2 plus 8 is 10 plus 16, 26. Any questions about that? Okay, now we have to do arithmetic using binary notation. So let's go to number 5. So arithmetic, this is 1 0 1 1 1 0 0 base 2 minus 1 1 1 1 1 base 2. So what is that number in base 2 minus that number in base 2? We have to do this arithmetic using binary notation. How do we do it? Well, it's just like regular arithmetic. You can't do 0 minus 1, right? You have to borrow from it. So, but you can't borrow from the first 0 before it. You have to borrow from this one. Now, by the way, you can't do this with the calculator. You have to show all this work on your paper test or else you won't get credit for it. So borrow from this one, make it 0, right? Then you'll have 10 right here, right? And then borrow from that 10, and you'll have 1 left to make this one be a 10. Okay, hold on just a second. Let's start over again. Hold on. Well, okay, first of all, did that make sense to you? If you borrow from that 1, you'll have a 0. Put the 1 on there, you'll have 10. Borrow from the 10. There was one thing that was not accurate though. If you have 10 and you borrow from 10, what's left? I didn't write it yet. Maybe I did, but I did erase it. If you borrow from 10 for the next column, what do you have left? Okay, let me start again. I just want to make sure this is making sense to all of you. Okay, so think this through carefully. If I borrow from a 1, what does the one right here represent? Which place value does that represent? The 1's place, the 2's place, or the 4's place? 4's, right? So if I borrow from that 1, I'd have a 0 left over, right? So I put a 1 right there. So that means I still have a 4 right there, but a 4 is represented in the 2's places as a 10, right? It's kind of confusing. So yeah, that's still represented as a 10. Okay, now, but remember that 10 represents 4 though. So keep in mind that that 1 0 right there actually represents 4. It doesn't represent 10 like we think of using our normal brains. So if I borrow from that 10 right there, and I take 1 away from that 10, how much is left? Hmm, you're not sure? Well, there still has to be a total. There still has to be a total of 4 somehow or another, right? So what's another way of writing 4? How could I write 4? So what if I had 1 left? So if I cross out the 10 right there, I would have 1 left in the 2's place and 10 left in the 1's place. That would still represent 4, right? Because 10 in the 1's place is the same as actually 2. 1 in the 2's place is also the same as 2. So this one right here, this 1, 0 right here in the 1's place represents 10, but it actually represents 2 because 10 in the 1's place represents 2. 1 in the 2's place also represents 2. So that still represents 2 and 2, which is 4. So does that make sense? Did you ever remember this? This is actually why when you're back in first or second grade learning how to subtract, this is actually why it was so hard because it's actually hard at first. Right? You have to logically think through what everything means. So now that we have this, what is 2 minus 1? Because remember the 10 we have above represents 2. What is 2 minus 1? 1. And then right above we have 1 minus 1. What is 1 minus 1? Correct. Now, once again, we have the same trouble. We have a 0 now, and we have a 1 below it. So how do we deal with that 0 above and minus a 1? We can't do it, right? We can't do it. So 0 minus 1 is impossible. So we have to borrow from this 1 right there and make it a 0. So we have to borrow from this 1, make it a 0, and then put that 1 up above, which makes 10. So you have 10 now. But remember, 10 represents 2, though. So what is 2? What is that 2 right there minus 1? 1. Right. 1. And then we have, we have 0 minus 1 again. And 0 minus 1 is impossible. So we have to borrow from that one. We have to borrow from that one, make it be a 0, and put a 1 on that one, and that we get 10. But 10 really represents 2, right? So 10 really represents 2, and what's 2 minus 1? 1, correct. So we've got 1, 2, 3, 4. We have 1 more to go. So we have a 0 there now. Can you do 0 minus 1 or not? No. So when we can't borrow from the 0 before it because that's 0, so we have to borrow from this one. So borrow from that one, make it 0. That makes this one be 10, right? Then you have to borrow from that 10 and make it become 1 to put a 1 on that one. Right? So then we have a 10 right there, but what's a 10 actually though? It's really a 2. What's a 2 minus 1? 1. And then we have a 1 before it. So the answer should, because we have 1 still left over minus 0, which is 1. So the answer should come out to be 1, 1, 1, 1, 0, 1. Like that. Perfect. By the way, how can you check your answer? Yes. The last 0. That one? No, that's 0. The other one. That one? That one? Yeah, why doesn't it come down? Why doesn't it come down? Yeah, to be 0? Yeah. Well, you could, but it wouldn't matter. Because if the first digit's 0, it just stays 0. Yeah. Right. So it doesn't matter. No, it doesn't matter because if you begin with a 0, like for example, if I did 541 minus, let's just say 91, like that. Actually, well, that's not a good example. If I did 141 minus 91. Okay, so we do 1 minus 1, right? And then we get 0. We have to borrow from this one and get 0. Make this be 14. Now what's 14 minus 9? 5. Then we have 0 at the beginning, but we don't have to write 0, 50. We can just write 50, right? Okay, any questions about that? So there's number 5. So I know that it's kind of a struggle to do arithmetic with binary notation, but to make sure you practice with it, just remember when you borrow from a 1, you get 0 left. That's easy. But then remember, make the next digit become 10, though. And if the next digit's 10, that actually represents 2. So just remember that a 10 represents 2 in base 2. Just like a 10 represents 10 in base 10, a 10 represents 2 in base 2. All right, let's look at number 6. So number 6 says E 0 B 16. And it says convert the integer from hexadecimal to decimal. So how do I convert the integer from hexadecimal notation to decimal notation? How do I do it? So a hexadecimal notation uses the same digits 0 through 9, but then it has, so that's 10 digits total. From 0 through 9 is 10 digits, but then it uses the first 6 letters of the alphabet to represent 6 more digits. So basically 9 equals 9, and the letter A represents 10, the letter B represents 11, the letter C equals 12, D equals 13, E equals 14, and F equals 15. So 0 through 9 are just the same as they are before. Hold on, I don't know why I used an arrow first. So 0 through 9 is the same, but A through F represents 10 through 15. And by the way, this is the ones place. So every base system starts with the ones place. But then the next place represents whatever the base is. So if the base is in hexadecimal, hex means base 16. So the next place after the ones place is the 16s place. And then the next place before the 16s place represents that times itself. Just like we have the hundreds place in base decimal in the decimal system, which is 10 times 10. The hundreds place in the 16 system is 16 times 16. So what is 16 times 16? That's the 256's place. So we have a B in the ones place. So we have B ones plus we have 0. Let me look at that. That's a 0. We have 0 in the 16s places, 0 16s, and we have E in the 256 place. So how many ones do we have? What does B represent? We have 11. So we have 11 ones, which means 11 times 1. And we have 0 times 16. And then we have E times 256. What does E represent? So maybe one person on this side of the classroom, on the right. One of you tell me which letter does E represent? What number does E represent? It's written down on that chart. Yep, 14. So 14 times 256. So what is 11 times 1? 11. 0 times 16 is 0. And 14 times 256, that's 3,000 and what? Perfect. So then we just get 11 plus 3584 is going to be 3595. So the answer is 3595 is the answer. So the number E0B is equal to 3595. in regular decimal notation. Okay, perfect. Oh, bother. What in the world? Okay, the next question had 4 different parts and I just like got them all ready and things. And then I had 2 files and I guess I must have printed the draft file before I had added the 4 different parts. So I'm going to skip number 7 and come back to it on Wednesday. Because it's missing the actual parts of the problem on my paper. But number 8, though, let's go to number 8. So let g of xy be the predicate. So remember predicates, they're kind of like logical functions. So g of xy is the predicate x squared is greater than y. And it says use specific values to create 2 true statements and 2 false statements using g. So using the notation g, you need to create 2 true values of g and 2 false values of g. So can anybody help me think of 2? Now, by the way, these should be different for everybody. I don't want you to all have the same exact examples written down on your tests. Give me 2 true examples of g. So, for example, if I just said g00, is that true or false? Is g00 a true or a false statement? So no matter what numbers you plug it in, it'll have to be either true or false, right? So should I put g00 into the true category or the false category? What does g00 mean? So somebody tell me what g00 means. G00 is what meaning? Remember, g of xy is the statement x squared is greater than y. So g of 0, 0 is the statement 0 squared is greater than 0, right? So is the statement 0 squared is greater than 0? Is that true or is it false? Is true or false? Arturo, what about you? Is that statement true or false? Is 0 squared greater than 0? False. So that's a false one. So a false statement, for example, would be that. Now somebody give me 2 other numbers, like 1 or 2 or 3 or -1 or whatever you want. 6 and -10. So let's go to somebody else. Logan, tell me what the statement g6 -10 means if the statement g of xy means x squared is greater than y. The statement g is 6 -10 means what? What is x? 6. So it means 6 squared is greater than, and what is y? Correct. So that's what it means. Now, Isaac, can you tell me whether it's true or false that 6 squared is greater than -10? True, you're right. So that's a true statement. So G, you can put down G6 -10 into the true category. Do you see how it works? So you have to keep on thinking of some more true ones and some more false ones until you have 2 true examples and 2 false examples, right? So I'm going to let you finish the rest of it. Okay, then the last 2 questions, we can do those next time. Sorry, not the last 2, but we have like 3 or 4 more to go. So the number 9 says, prove the following statement, the difference of any 2 odd integers is even. And then number 10 says, show the following number is rational. And then number 11 says, how many zeros are at the end of a number? And then number 12 says, what is 4b mod 12? Then it says, find the values of after the loop. And then it has you prove something, and then it has you solve a recurrence relation. So we can finish the rest of it next time. So, and I'm going to also post the review in Moodle once I get the formatting back the right way. So make sure you studied that in Moodle. Make sure you're ready for Monday. And make sure you do your best on everything. And then by the way, we don't have class on Friday. So our test is going to be on Monday after fall break. So good luck, everybody. Keep up the good work.